So the next part that we are going to work with is the main context of the entire conference. We are going to talk about how we are transitioning the entire 3D models or 3D work into 4D or 5D BIM. And for that, I have a technical expert with me from Bentley, Anik. Can you just please come? Yeah, just please give him a big round of applause. And so with this, I'm handing over to Anik. Just please. Thank you, everyone. Over to you. This is for next, okay?
Okay.
This is for laser. You want color?
No, I got it. Okay. Okay, so I'm going to start this presentation with very fundamental questions. I know all of you are from construction industry, but let's think this. So what is construction fundamentally, and what are the steps involved in construction? Now, if I say that construction starts with an imagination, it starts with an idea, and then we communicate this idea to the people around us. So, and we communicate that saying that what exactly we need, and then we share some information saying that what we need to construct. And if you think very fundamentally, all the constructions we see around us is somehow philosophical level, these three steps are always involved. And these three steps, how efficiently we do, defines that how successful our construction is. But sadly, most of our construction is not always very efficient. If you see the statistics, many of our previous presenters said that it's not always the efficient one. So we can see that there are 20% of the projects which overruns, and 80% of them are the budget overruns. And while in the construction we generate a huge amount of data, but hardly only 4% of the data we can utilize for decision making. Now this is a very big challenge, and we know it. But is there something we can do by introducing a very simple process or a solution that can improve this situation? So that's what we are going to learn in the next few parts. My name is Anik Mal, and I am the Product Success Manager at Purchase Bentley Systems. For the last 3 years, I have helped more than 50 organizations around the world to adopt 4D BIM, which has helped them to move from 3D to 4D, and in this journey they have become successful. So I'm going to share this information with you, how you can also move from 3D to 4D, what are the benefits, and what are the exercises that you should do while you are taking this journey. So if we see the stages of any construction project, we know that there is planning, there is design, there is construction, handover, and operation. There is one particular phase which we often miss out, is the pre-construction phase. And this is very important while we are dealing with any of the large project. And if we talk about the 4D BIM that we have been talking so far, it starts somewhere around the 4D, the pre-construction stage, and it goes until the end of the construction. Now, this is the kind of a spectrum which comprises lots of BIM usages that we are going to see later, but mostly it starts in the pre-construction part, and it deals with whatever we have done so far till the design stage. We are going to use that 3D model or the 2D model or the plan, and we are going to start using it in the pre-construction stage, and where we start to see the benefit in the construction part. So before I dive deep into 4D, let's talk about the present practices that we are doing. So before I go deep into this one, so I just would like to know that how many of you deals with 3D model, or at least somehow involved with the 3D model. Can you please raise your hand just to see that how many people are here? Okay, that's a good number, and that's the trend what it is. So we have moved from 2D to 3D, and it's a very, there are lots of benefits of 3D. But there is one very big limitations of this 3D model, is that this 3D model is a static model. It is very accurate model of the built asset, but it does not talk that how exactly the construction is going to happen. It does not communicate that how exactly we are going to construct these steps. And when we follow this BIM model or follow the drawing, which are created based on this 3D model, again, those informations are missing. So somehow to consider the part where construction is dynamic, we have to make this model a dynamic which can further communicate the construction process. Now the next part is the plan or the bar chart. How many of you daily interact with a bar chart or have a bar chart? Okay, so that's great. Now bar chart is a very efficient one. We have been doing it for many years. But if you think again, while creating the plan, we actually do not see what we are planning. It's most of the time based on our experience. It's most of the time based on imagination that we have in mind. So we cannot see what we are planning, and we can say that if we cannot see what we are planning, then how can you say this is the best one, or we do not have much options? So one of the biggest drawback of planning using the traditional conventional tool is that we cannot see what you're planning. Now, I'm not saying that these methods are inefficient. I'm saying that we can make it more efficient by adopting some more digital solutions. Now, 4D is a solution that that involves this 3D and the planning and also the people who are involved. Now, another thing is that while doing the constructions, we run into errors. And how do we communicate these errors? Most of the time we call someone, we WhatsApp someone, or we raise an email. So how this set of communication is connected with the plan or with the 3D models that we have been using? It's happening in silos. The communication is one place and the plan is in the other place. So if there is a delay, then how does your stakeholder know why there is a delay? We have to go back and see for that email chain where people are fighting to resolve something. And there is a lack of transparency while we are working. So that's something the unstreamlined communication also need to, that's a problem, and that also need to be, resolved. So this from here, if you see that the 4D concept starts with combining your 3D model with the plan that you have. Now, when you say the plan or the schedule, this is the time information we are talking about. So the plan is basically a part of the time information, right? And we are combining these two things together to create a 4D model, or the process of 4D starts from here. Now, this time information is not just about the schedule. It has again two different parts. So one, this time information should say that how your project should progress with time. And second, equally important, which often miss out, is that it should also communicate how your project is actually progressing with time. And there should be a close feedback loop between these two parts. So how things are supposed to happen and how things are happening. And we know that things will not always go per plan, so we need to be prepared. And all the stakeholders who are involved, they should also see what things are happening. And in the decision making, they should also be there while they take a new decision. Now, this whole thing that I have just talked about, and it aligns with the philosophy of digital construction. And keeping this philosophy in mind, we have the solution that helps us to implement this particular philosophy in any project. You talk about building, you talk about roads, rails, airport, or even the offshore projects. So we have something called Synchro4D, and note I use the term solution because it actually helps us to implement this philosophy using different services and products. So we need the first thing that we need to do the planning, to creating the 4D plan in the beginning. And the first thing we require a 3D BIM model. And the second thing we require a schedule. So BIM model we use, most popular one I believe is Revit. And there's Navisworks, IFC, there's Bentley's DGN format. So you can take all of them inside Synchro, and it's not only the one I have mentioned up here. There are more than 50 plus CAD formats that you can take in. And talking about schedule data, so schedule data, you can create it from the scratch by looking at a model. So that's what something we want. Or maybe we can quickly create a outline or lower level schedule in any of the following conventional planning tool like P6, MSP, Astapower Safran, and take them inside Synchro. So when we take them inside, so this is where we start the journey of the 4D. So you see in the top there is your schedule, and in the bottom you see your BIM model. And this is exactly where we start the 4D modeling or the 4D planning. Because as a planner or as a people who you are going to decide at how the construction is going to take place, you start tinkering and tweaking with this schedule, and you start seeing that what is the best one. Now, Synchro is a full-blown CPM engine, so whatever the features that you have in a conventional planning tool, those options are all of the features like the critical path method based on forward or backward or based on the least float path. So all of them can be done up here, and you can start creating your 4D model. So when I mean by start creating a 4D model, let's start with an example up here. So this is a schedule which is a lower level schedule we have, and as a planner I start deciding that it is missing some task or we need to plan something better. So we start seeing that okay, there are some tasks which are missing, so we start adding some new activities. Here we set for the part which belongs to the hierarchy of the structure, and then we start creating the required activities. Now while creating that, we link it with the 3D model. The advantage of doing this, we get an visually interactive plan. So what do we mean by that? Let me show you. So here we have added a new task, and let me just pause it up here. So here we have added a new task, and you see that we have also added the logical relationship. You can also control that whether it's forward, finish to start, start to finish, what the logical relationship is. And we start reviewing that how our plan actually looks like. So this is how it looks. So when you go forward and start adding all of this part, and you start visually seeing your plan, that how it looks like. Now at this point when you start seeing how your plan looks like, so this is where you can try out different plans, or before you settle down with a particular plan, you get to choose different options. You get to optimize your schedule based on the best methods out there. So here, let me show you another example up here. Now this is a slab from the design model which is 54 meter long. And here we just have one task that has been previously planned. Now you tell me whether we are ever going to construct a slab of that long in a single stretch, or it doesn't communicate the information how this slab is going to be constructed, from which part the construction is going to take place, or where the equipment is going to stay when this construction stays. So just imagine the bottom part is missing, and you just take this bar chart to the people in the construction site, and they would not know how they need to do it, and they have to decide there while planning. So we can make this much more efficient, where we can make this model a bit more constructable. Now the design model are model keeping the design in mind, but not the constructability. In reality, this slab is going to be constructed in 3 parts. So to make the model constructible, we have to break it down into 3 zones. And to make the model constructible, we have something called Synchro Modeler. It just helps us to break down your design model that you are going to use using different methods. So for example, here in the slab, we are going to do it in 3 equal parts. And you would be seeing that we select one edge of it and we divide it on 3 equal parts. Or it might happen your pouring schedule, you want to divide the slab based on a particular a particular zone. So in the next part here in this zone, you see that you want to first construct the one corner. So you need to break it down using your freehand slicing techniques, where you provide the boundary to break the model. Now it's not only the slab you can break. If you talk about a large linear infrastructure project, you need to break it down by zone. or if you need to break it down by the zones that contractor is going to work. And keeping those parts in mind, this is where Synchro Modeler helps a lot, where it makes your model much more constructible, and which is practical, which is what you want in your project. So moving forward, now we have we have planned, by looking at the 3D model, that we have added 3 more tasks in below it here, saying that how the slabs are going to be constructed. So now it also shows that in the direction this construction is going to take place. So here, if I play and I see it right at a time, that how my plan looks like. So it's an interactive, intuitive visual planning method, and we see that we are going to start the construction from left to right. Now imagine just sharing this only the Gantt chart and compare with sharing this information. Which one do you think will make more sense to the people who are actually going to do the construction? And it's not only that, you can create your whole schedule from the scratch, because your design model contains most of the elements that you are going to construct. And the approach of doing 3D model is something we called 4D model based planning. So let's say that we have done a very good plan, and still one part we haven't considered is the logistical planning. So the another thing is that these Gantt charts are not able to communicate is that where the equipment are going to stay, when the equipment are going to move in. And we want is not only that we want an animation of things going in, so that has to have some time information in it. And by time information, accurate time information. That means these equipments are also be treated as a 3D resource which will be assigned to the task. So if we go a step back, so if you consider these slabs is going to be constructed at one particular time, and that's when you want the equipment. Now it's not just that equipment is an animation of showing moving in. You want to have the information when the equipment is will move in, and based on that you maybe plan that you need to clear out the path of that equipment, or whether or not your path is clear or ready to accommodate the equipment. So that's where the equipment planning starts. And if you have any equipment representation, or it doesn't matter the representation, a box can be treated as an equipment, and you just have to do temporal and spatial coordination planning. So here, for example, you can see that we can just simply import one 3D model and treat it as an equipment resource. Now I emphasize on the term resource because this equipment may have a productivity rate. This has a property which are aligned to what we call a resource. So once we have the equipment, we start planning out that what can be the base location of the equipment, whether or not that site able to accommodate the equipment, or how it's going to enter. So we can plan it very easily. It's not something very difficult, or if we can even plan out the path of the equipment, how it's going to move and when exactly it's going to move. So here, for example, when we do it, and you can see it live in front of you after doing the plan. Okay, this is the plan for now which I have decided. Maybe I can change it later, and that's what we have. And this is a very simple example. If you want to see some complex example of logistic planning, that in the next part here, Courtesy Metro Tunnel, here you can see that how equipment planning plays a big role. Now here, if I just pause for a moment at this particular level. Now this is a huge construction site, and here some excavation are going on different site. Now imagine that you have just done your planning and you have left it to your contractor to do this decision. Now the people who are in the construction site, they do not get the bird's eye view, and they do not have the idea of how in terms of scale how things are going to happen. So now once you start your planning, your 4D approach, here you start planning out that how the equipments, your Moxie trucks are going to enter this site, how they are going to, the dumpers are going to take out the earthworks which has been excavated. And while doing so, you start optimizing that you start optimizing that whether or not, can we run two activities in parallel at different sites, whether or not that is feasible. Now this is where you start, saving a lots of time, because now you have the options to take this kind of decisions in front of you. And we have provided a kind of, if you see, if I just pause one more time up here, a balloon in around the equipment which says that there is a chance or a clear area it requires for turning, turning radius, and whether or not it is at any point it is clashing with any of the elements or not. So this is a very good example of how an efficient logistic planning can help, or at least having this data in front of you before the construction can help the people who are actually going to do the construction. And this is something what we call digital rehearsal, because we are actually doing the the rehearsal of the actual construction before the construction. So here is another example when we say the logistic planning. Now this is a very busy road, and we there have to install quite a few plate girders. And here again we have this people have planned out that how they are going to lift and place these plate girders. So for example, when exactly they are going to start the construction, whether or not there is enough space to accommodate these objects which are going to be constructed in the site. So again, this has been planned out, and it has been digitally rehearsed before the actual construction has been done. And this kind of exercises actually saves you from accidents, actually make your project much more safer, and saves time, and saves money. So moving forward, there is another part which is a part of the 4D planning, is the workspace planning and the dynamic class. So we know the coordination class, which you often do in the design stage. That's about finding out if two elements are clashing at any point or time. But what about the clashes that can happen during the construction? Or what are the clashes that you want to avoid? Those can be soft clashes, or those can be hard clashes. So for example, there is a particular zone and it's a green space, and you want to protect it at any level. You don't want any equipment to go near that zone. And how do you run a simulation? So while doing your equipment planning, you find out that that path is getting encroached by the concrete truck that you're using. Now this is an example of pure dynamic class where no time aspect is involved. But let's consider another situation where you are utilizing same space for two different purposes. The same space has been used for a concrete material storage, and later it can be used for the steel material storage. Now at a particular time, you see that two areas has been utilized by the same resources or same purposes. Now this is an example of what we call a spatial temporal class, and if you compare it with the traditional bar chart, you could not never find out that where exactly these classes are happening. And when you find out these classes are happening, probably you need to change your plan a bit. You have to make sequence in a different way so they do not clash, but you can utilize the same space in the same time. So these 3D aspects, when combined with the time, can bring a lot of benefit. Now the other thing which is quite important, which I've been talking about, you want to try out different plans or different options before you choose for the best one. Maybe you are doing a coordination meeting with different people. They share different idea. Okay, what if we do a particular construction before, or what if we try this one out, and how what will be the impact? So here you see 3 schedules. So if we just see 3 different colors, so one is in the pink, one is in the blue, and one is in this particular part. So 3 baseline represents 3 window that you have here, 1, 2, 3. And you see in front of you that what's the impact of the different baselines, and which one is the base, on which one you will feel like you will be most efficient or the optimized one before you go for the best one. Now the side-by-side comparison is not only about the baselines or the scenarios that you want to try out. It can be even something for the plan versus actual when you are doing your review meeting. So here, for example, we have two baselines, one for the planned, one for the actual. How we collect the actual information from the site, that I will come to a bit later. But here we can see that, what's the difference between the plan and the actual, and we are seeing it side by side. Now, just looking at the planned, that might have not, convey it in the intuitive way you want it to be. But here, things, at least you get some idea that where you are deviating, and maybe you can question better that why there is a delay and when the delay starts. And when we say about the actual, we collect data from the site, and can we do the data analysis further on it to do a better decision making. So here, for example, we started accumulating the actuals data from the site, and we start seeing the variance of the start date, and we have created a heat map. Okay, now consider that you just have this data in your bar charts, and you couldn't have communicated, or you couldn't have questioned the way when you have the data imposed on top of your 4D model. Now you would see that the blue, the color is there is no delay, and the red is the color, the more delay there is. Now we have imposed this color on top of your 4D model, and here you can start questioning. Okay, that we can see the top part is a color where we can see a 10 days delay. Now you can start questioning that why we get a delay in when we start constructing the steel, whether there is a delay in arrival of the steel elements, or why there is one particular column which is in color red. Okay, so why there is a delay in that particular column, what's the history involved between that column. You start questioning better, and when you question better, and even if you do not have answer, maybe after knowing that what issue you got, maybe in the next time you can take a better decision on modify your plan maybe a bit, or modify your 3D model, or talk with your contractor to prevent that. Now that kind of information having and representing the data in the correct way is very important. And you should note that your time information data, your 3D model, all are getting accumulated at one single level. And that's the why we want to have this data. And these are the exercises, something that you need to do in the while doing your construction or while in the pre-construction part, and you need to keep on carrying it. Now, so we have the time information, we have the 3D model which are linked with your schedule. The other thing which is missing is the 5D, the cost information. So how do we get to the 5D part? So we know that cost is a function of physical quantity and also time. Okay, so when we do costing, it's most of the time a BOQ based cost based on the physical quantity, but we do not consider the time aspect, or we do not able to combine the two things together. So let's say that at this point in Synchro, what are the information we have? We have the schedule, and the schedule are linked with the 3D resources. So what's the advantage of that? So from that point, we start accumulating the physical quantity of the 3D resources which are assigned. So let's say that there are 3 activities for the piles, and for each activity we are constructing 50 piles. So what is the total concrete that is going to be used? So we have list down from the 3D model itself. Now since it is connected with 3D model, you do not have to have you can start comparing to your baselines that what is the what if you take a different approach, then how your baselines would look, or what is the difference. Sorry. Now if you start putting your actual dates, or if you start bringing your actual information, you start getting the earned value curve. And here you not only see the curve in form of just graph, you can question that okay, why there was a delay, and even if there is an actual something like this. So I will just move here. If you have information like this, so you supposed to see all of the 3 things together, that is your plan, your cost information, and you see that what's the work you have done so far. Now if you are working with a contractor and they submit, or they say that we have done this amount of work, so what does it mean and how much cost that should do? So you get all of the information at one single level, and we are talking about a single source of truth in this construction project. And later I will say that, what we mean by that single source of truth and how you can utilize it further. So moving back, there is other benefit of having your 3D resource management is that when you have the physical quantity data, you and since the time information is also there, you can see that what is the daily concrete consumption for the whole part. Now, let's consider an example where you're doing excavation and you have limitations on the total excavation you can do a particular time. And there are some parallel activities going on, and you found out that it's the excavation rate is actually exceeding the particular your total capacity, and at that point you need to change the task. You need to make it move so that it doesn't exceed the capacity. Now we could have done that in other application or in Excel, but the connectedness with the 3D model and how parametric the whole thing is something very important. So here we can see the daily concrete consumption, and we can see the cumulative graph of consumption, and maybe it is some other resources where you can see that total available resource is this much, and when exactly the cumulative consumption is exceeding your resources which are in your reserve. And from that point you can start planning or start planning that how to bring extra resources. Okay, so far what I have talked about is about doing the planning and how your plan is supposed to look like, or how what is you going to follow. But I haven't talked about that how to know how things are actually going in construction site. So we need to involve the people in the construction site, and what is the way of connecting everyone together? We need a cloud solution. And the cloud solution we have is called Synchro4D. This is where we host our 4D project, and 4D project are hosted as a form of I model which acts as a single source of truth. Now in Synchro4D, this is not just a CDE. CDE, what we know, the BIM 360 or the other CDE we have, those are mainly used for the design purposes. Now the design purpose CDE and the construction purpose CDE is a bit different. The construction purpose CDE would have to involve lots of other things that we do not often consider in the design phase. So for example, we have the 4D model, and we want to have this 4D model to visible to all the people who are in the construction site. For that, they can use the mobile application that's called Synchro4D in their handheld devices. They can not only review 2D drawings, 3D model, they can actually review the 4D model of how the construction is going to take place. Furthermore, they can update photos, they can update videos, they can update site logs, RFIs, or any forms they want to update from site. And these forms is also connected with the 4D model or the 3D model that you have. And the other important aspect is that when they are updating information from the construction site, they will also update what is the resource status, what is the progression status at the resource level. Now let's see how it looks inside Synchro4D. Now this is an internet browser, and inside internet browser we are opening the Synchro4D project. So here we can see the Gantt chart, and along with the Gantt chart we can see the 4D model. So we play it and we would be able to see that how the construction looks. Now why things could have been reviewed in the 4D Pro, but not all stakeholders required to have a heavy application installed in their system. They want to have something very easy, basic. They just log into the internet browser and they check few details. It may be your contractors, okay? Your contractor doesn't need to be heavily synchro efficient to know this. They just need to review the 4D model so that they know what they need to do. And while reviewing, they find out that there is one particular issue with 4D planning that they are not comfortable with executing in the site. So they say that, okay, the equipment part which has been proposed is not feasible. The path, there is obstruction that cannot be fixed, or the site is not strong enough to accommodate your equipment. And we start saying that, okay, what this issue is about, instead of raising an email or calling or starting a huge chain of conversation, we just, at this point, we just start saying that who is the person who is responsible for fixing it. So here we just mentioned that I assign it to a person who will be responsible for fixing it, and we assign a due date within which that particular person need to respond. And this whole communication gets saved in the synchro control, and that's what I'm saying, that everything, whatever you do, whatever you communicate, start consolidating at one single location, and you can use this data later for other kind of analysis. Now, while raising an issue, we start saying the geolocation, where exactly the issue is found, okay, so that maybe later you can do site visit for better planning, and we can start saying with context to the 4D model that what that need to be fixed or what something is wrong. So maybe we can flag one issue, or maybe we can create one markup if required. So when this issue is raised, the particular person to whom it has been assigned, they will get an email saying that one issue has been assigned and you need to fix it. Sorry, just okay. Now this is inside the internet browser control. Now how the same thing would look inside the mobile application. So here we go inside the mobile application and we start reviewing the same project. Now this is meant for the people who are in construction site. This work in both offline and online mode. And now we start seeing that how this project looks. So we go to the respective project to whom I have been assigned. I can review the same 4D model that I've been working with. The person that go inside and they just check what is the look ahead, how the construction looks in next 2 weeks. Just go and review. This is not a 3D model, this is a 4D model. So here they play the timeliner and they see that probably from one date to another date, the look ahead task or the look ahead construction would look like for them. And this information to start the construction is very important. And that's how we want the communication to be done in a streamlined manner. So once they review, they can raise an issue in the same way we have done earlier. But the best way is that we can start saying the progression report. So here from the mobile, we start saying that, okay, the resource status. So we say that this particular slab, which previously the formwork was completed, now the rewiring is maybe done. So here we say, here we change the status. Now the casting has been done, and we say that when the casting was completed. So these are the milestones that we have for a particular task, and we update what are the milestone and when the date it was and the time it was completed. And when we start updating this information from the site, the whole thing gets synced back in your Synchro4D Pro main model. So here is another information. We say that the tasks which are in progress now complete. We select a resource and we update the information. And now here inside Synchro4D Pro, this information gets synced back through the cloud connection. And here you would be seeing that there is a color coded information which says that what are the part in what are the different stages. So here, for example, we see that some of the slabs are in the stage where the formwork is done, and some of the stage where rewiring is done, some of the part where the work has not been started. Now when you see this information in your 4D model, you can get an idea of which stage your project is in. And if you compare it with just the 3D model or just the Gantt chart, it doesn't communicate this information the way this color coded 4D model communicates. And now these are each of the BIM uses or the exercises that you need to do before you reach to the end part. Now as I was saying that we have been collecting data so far, but how can we use the data for the later purposes? We have the data source, the 4D model. This 4D model is very smart, and inside this data source we start accumulating the 3D data, we start accumulating 4D data and 5D data, and even the site update. So all inside the same model. So we need to do some kind of advanced data analysis to get more insight into this. So what we have, there is a connector for this data source. You can create your Power BI dashboard and create some advanced dashboard based on your requirement. And you can publish the same Power BI dashboard inside the Synchro control again for everyone access. So for example, we can create some advanced dashboards like this one. These are some key information maybe you want to see at a glance at live or something like this. So in the concluding part, I would like to end with these few questions. So what would you prefer in your construction project, a static 2D or 3D model, or do you want a very interactive model which tells about the whole story, how the construction is going to happen? Or how do you want to have your planning? Is it going to be the only planning where you leave everything to your imagination, or where you want to plan by looking at your 3D model and you want to do a model specific planning? And finally, your data and the document management part. So in any construction project, we create huge amount of data, be it digital, be it physical. So, and these data we cannot use because they are scattered at different level. We want to bring all data at one single level, and we want to utilize those data. So here, everything gets stored in one single repository of the cloud, that's in Synchro control. And finally, how would you like to have the communication? Is it just in a separate chain of communication which you start with different people through email, WhatsApp, or do you want to have them connected at one single location where everyone knows how your project is going in a more transparent and in an accountable way? So finally, what the traditional method I have talked about, those are, I have nothing against them, but we can make it efficient. We can make it much more efficient, and it doesn't require a very steep learning curve. If you know 3D, if you know planning, then you just have to combine them two things together, and that's just simple the linking that you have to do. And by implementing or by adopting this 4D, there are people who have done very easily, and they have just spent some time on it to doing it. And you will not be alone in this journey of adopting. So we and GKC team is going to be there to handhold you and make you successful. And we have done it so far in India. There are many success stories which GKC's team has shared. We have lots of success stories inside Bentley. And I strongly believe that if you know 3D, if you know reading the bar chart, then this will be a piece of cake for you. All you need to do is spend a bit of time and to start this journey. So that's where I'm going to conclude my presentation. We look for your Q&A later.
Put that G presentation वापस. Just hold on. Yeah, mic. Yeah, thank you, Anik. Thanks a lot. So why I actually put this again, I love this slide a lot, and there are certain things that he took before ending it up. These questions that we talk about, of course, these things makes a lot of sense. So when we say which one you would prefer, so preferring is, it's not just like we're talking about the simple paperwork or a proper dynamic model where we can actually see that how our project is progressing, how it is growing, or how it will progress. And instead of just comparing the Gantt charts, what happened? Okay. Instead of just comparing the Gantt charts, we are able to compare model to model. So it's always good to have a great and clear visualization of your projects. That gives us the real understanding. And even a layman who's actually not a project management guy or who doesn't have the project management adequate knowledge can make out with the help of these visualizations that yes, what was planned, what is happening, where we are, and all those things. Next, about the document management, when we talk about, it's part of CDE, right?
Yes.
So instead of just looking at the documents here and there, we can have a common data environment where we can actually have all the connected strengths. It includes your RFIs, your checks and all that part, issues which are coming in, what checks have been done, what updates are there, and finally, communication. Of course, that's a big part. Sometime back I heard that almost 80% of a project manager's or project team's time goes just on phone call, on communication. because they don't have the clear understanding, clear data out going in. If you have a single source, or when we talk about it's all connected, you don't have to wait for somebody to give you the report. You don't have to call someone to check that what's the status. Just log in and you can check there in it, right?
Right.
So this is how it works.